Continuing with the unit review for Unit 2, this is number 48. So remember the same thing, guys. When it comes to fractions, we want to eliminate the fractions, right? So what I'm going to do is multiply by an LCD, and they're different fractions, they're different equations, so I don't have to multiply by the same number. So this one here, I'm going to go ahead and multiply everything by 6. And this one here, I'm going to multiply everything by 12. Okay. You can cross cancel. I wouldn't recommend it. People tend to make more mistakes than good things. So remember, just don't forget to distribute everything. So we're looking at rewriting this as 6x over 2 plus 12 over 3y equals 30 over 6. Over here we're looking at plus 72 y over 12 equals 36 over 4. Alright, and so we're looking at reducing everything down now. Alright, let me just check my multiplication here real quick. Yeah, I knew I was off a little bit. This is 84. Okay, so this is 5x plus 7y equals 9. Okay. Up here we've got 3x plus 4y equals 5. So I know I got this kind of a little messy here, but there's my two new equations. Now I got to get rid of something, right? Do some elimination. I just reduced everything down right there. So I don't know, I'll get rid of the x's here, I guess. So I'm going to need a negative 15 and a positive 15. So I'll make this top one the negative one, and I'll make this one the positive one. Okay. So rewriting this again, I now have negative 15x minus 21y equals negative 27. Down here I got 15x plus 20y equals 25. Those cross out, and I get negative y equals negative 2, so y equals positive 2. Go back and plug that in, and it doesn't matter where you plug it in. I'm going to plug into this one right here before I multiplied by 5. And this is going to give me 3 times x plus 4 times 2 equals 5. Scoot this up so you can see here. Equal plus 8 equals 5, subtracting 8 to both sides. 3x equals negative 3, dividing by 3, and x equals negative 1. And realizing the answer is a coordinate point, there is my solution. Okay. That is quite a challenging problem, but I think we should be able to do it. Okay. Looking at question number 50. This is a question with some decimals in it. When you clear a decimal, the only issue is you tend to end up with big numbers. But it shouldn't be an issue because you are allowed to have a calculator in this course. So I got to realize how many spaces I need to move it, right? So in this top equation, I got to move it 2 spaces to clear it, and this is probably where the mistake's going to occur. So I don't just get to move the decimal place over, right, and just get rid of it. No, I got to multiply by some value, and I got to move it 2 spaces. I'm going to multiply by 100. If I want to move it 1 space, multiply by 10, 3 spaces, 1,000. And so this top one now becomes 315x. Now this right here does not become 17y. It becomes 170y because I moved it 2 places. Equals negative 95. Okay. Down below, I only got to move it 1 space. Right? I only got to move it 1 space. So I'm only going to multiply by 10. Okay. And then I get 45x plus 11y equals 12. Okay. Now I got to pick one of these to match these up. I'm hoping 315 is divisible by 45, and yes it is. So what I can do is multiply this bottom one by -7, because 7 times 45 is 315. Okay. So I'm just going to leave the top one alone. Okay, and then down below I'm looking at negative 315x minus 77y equals 12 times 7, I believe, is 84. But it's a negative 84. Okay. All the way across here, those cross out. 170 minus 77 is 93y equals 195 plus 84 is negative 279. Hopefully that's divisible by 93, and it is. Y equals negative 3. Yeah, like I said, you can have a calculator, so this shouldn't be overwhelming. Now I need to find the x value. Once again, I'm going to plug into this one before I multiplied by 7. So I get 45 times negative 3 plus 11, y equals 12. And 45 times 3 is 135 negative. So 11y equals 12. So I'm going to add 135 to both sides. Gives me 11y equals 147. Right? And it looks like that doesn't divide evenly. Hopefully I didn't make any mistake in my multiplication anywhere. But a fraction is an acceptable answer. Okay. So I'll get that right there. And so it looks like my answer, barring I didn't make any multiplication errors, over, 11. All over 11. Now we're on to question 52. This is a systems of equation word problem. And so we're looking at here saying, okay, tickets to Faith Hill cost $100 each in advance and $300 at the door. Mary Lou spent $2,400 on 16 tickets. How many did she buy in advance and how many did she buy at the door? Okay. So our first thing is we got to set up variables. Okay. So I'm going to say, this is number 52, I'm going to say x equals the number of $100 tickets. And I'm going to say y equals the number of $300 tickets. Okay. We know she bought 16 tickets. Okay. So if I add up all the $100 tickets, or the advanced tickets, plus the at-the-door tickets, that's 16 tickets. Right? I don't know what combination of each, but that's basically what it's going to be. Now, then the other equation involves money. Okay, so this is going to be $100 times the number of how many were bought in advance, plus $300 times the number that were bought at the door, and that equals $2,400. So I can go ahead and work this out. What I'm going to go ahead and do here is divide everything by 100. Okay. And so now I get x plus 3y equals 24. Okay. And I'm going to bring this one down, put it right underneath here. I'm going to multiply this by -1. So rewriting this, leaving the top one alone, gives me negative x minus y equals negative 16. Crossing that out, I get 2y equals 8. Divide by 2, and y equals 4. Right. So I got 4 tickets. She wants to know how many of each, right? So we bought 4 at the door, and we bought a total of 16 tickets, right? So that means we got 12 in advance. 12 in advance. 54 says graph the system of inequalities. All right. So it gives me y is greater than or equal to negative 2x, and 2x minus y is greater than or equal to 1. Well, the first thing I want to do is, I know I'm graphing these, so I like y equals mx plus b, or slope-intercept form. So this one's good to go. I just got to think of this as a plus 0. So I'm going to put a box around it, as that's the one I'm going to use for one of the equations. This one here, I want to manipulate it and solve it for y. Okay. Now if you look at this, it's not solved for y yet. I got to divide by negative 1. And this is where they're going to get you. Flip that sign. And there you go. Now I'm going to put a box around this one and realize those are the two that I'm going to graph. So let's start with this one up here. So the first equation I'm going to graph, I'm going to rewrite it here because I know we can't see it anymore, has a y-intercept of 0, alright, and it goes down 2 spaces over a space. This is a solid line because it has an or equals 2. Okay. The y's are greater than, okay, so I'm going to shade up here. The big issue here is if I want to test a point, I can't really test 0, 0 because the line goes through 0, 0. So test the point like 1, 1. Okay. Over here, I have a y-intercept of negative 1, and it goes up 2 spaces over 1. This is also a solid line. And this one, the y's are less than, so it's in the shade underneath here. So if you want to know where the solution is remember it's where the shaded regions overlap, and so that's basically in this region right here would be my solution. Everything in there. That's where the shaded regions overlap. Okay. Number 56.